After discovering that all the storm's eyes of the 2017 hurricane season were attracted to and steered by Doppler radar, came the daunting task of reanalyzing the entire last 100 years of history to find out when the research and development could have happened that would allow for such a monstrous rising up of a daily and severe weather system in our midst. After a study of the significant tornadoes list of the World History Project, one in particular not only stood out, but led directly to Tesla's Wardenclyffe Tower just a little over a month before it finally got shut down, allegedly because a couple of German spies were seen hanging around it. Why destroy a tower that has allegedly sat idle according to official reports, having lost its funding years earlier, just because some spies are hanging around if there's nothing of significance about the tower in the first place, and it stands as a trophy to Nikola Tesla's failure? Could there be more to this tower? What was even possible electrically at the time? Knowing I was not very electrically inclined, I knew I needed to learn some more about electricity's history, never mind that of wireless directed energy's history, before I could hope to glean when weaponized Doppler could have crept up in our midst, stealing our moisture in storms, leaving us in a world of hot water. First of all, electricity cannot be invented because it is, and has been known about for at least as far back as 2750 BC, when ancient texts documented shocks from electric fish, catfish, torpedo rays, though electricity remained a mystery until 1600 when William Gilbert coined the term electricus after studying electricity and magnetism. The term electric and electricity didn't get coined until 1646 in Thomas Brown's Pseudodoxia Epidemica. The first electric battery and the first transmission of electricity was in 1800 and is credited to Alessandro Volta. In 1824, William Sturgeon invents the electromagnet, and in 1831, Michael Faraday creates the electric dynamo, which is the first practical crude power generator. In 1830, the electric telegraph is born publicly. 1842 sees James Clerk Maxwell, Scottish physicist, develop 4 laws of electromagnetism, demonstrating that electricity, magnetism, and light are all manifestations of the same phenomena, the electromagnetic field. Thomas Edison and Joseph Swan both invent practical incandescent light bulbs in 1878. And by September 1882, Edison merges with Swan, and his DC direct current system powers New York City street lamps. Then, in June of 1884, America was graced with the arrival of a young Serb from Croatia in the Austrian Empire, the 22-year-old Nikola Tesla. He went to work immediately at Edison's machine works, helping build up that large utility in New York City. But after Edison reneged on a financial deal involving the development of arc lighting, Tesla figured he deserved better loyalty for his hard work and quit after only 6 months. It didn't take long, but by January 1885, Tesla founds his first company, the Tesla Electric Light and Manufacturing Company in New York City, where he went back to work on patenting an arc lighting system. War of the Currents commences and would continue until 1912, when Tesla's alternating current would win out over Edison's direct current system. The war getting over the top with Edison's electrocuting animals and even a poor elephant named Topsy at Coney Island, video still available today, to show how dangerous Tesla's DC system could be. Spoiler alert, Tesla would end up winning out, and it is his system that you and I use today. But that's getting ahead of ourselves. It wasn't until 1886 that the existence of electromagnetic waves was first proven conclusively by Heinrich Rudolf Hertz. 2 years later, in 1888, Tesla begins his research in the area of wireless telecommunications and alternating current power transmission. United States Patent Office approves his patent for an induction motor and a system for the production, transmission, and distribution of electrical energy. The basic patents of the polyphase system electromagnetic motor, number 381968, electrical transmission of power, number 382280, system of electrical distribution, number 381970, and another 4 patents were granted to him on May 1st from 1888 to 1891. He secured a total of 36 patents, which allowed him to completely develop what was known as the Tesla polyphase system and created the basis for the Second Industrial Revolution, aka the Technological Revolution. By 1890, Tesla began his experiments with high-frequency currents. His first work on wireless power was demonstrated on November 2nd, when he demonstrated his plates connected to a powerful oscillator glow in the field between them. 1892. Tesla delivers his lecture Experiments with Alternate Currents of High Potential and High Frequency in London. He notices heat value in experiments converted out of mechanical energy. In My Inventions, Tesla writes, "One day, as I was roaming the mountains, I sought shelter from an approaching storm. The sky became overhung with heavy clouds, but somehow the rain was delayed until, all of a sudden, there was a lightning flash, and a few moments after, a deluge. This observation set me thinking. It was manifest that the two phenomena were closely related as cause and effect, and a little reflection led me to the conclusion that the electrical energy involved in the precipitation of the water was inconsiderable, the function of the lightning being much like that of a sensitive trigger." Here was a stupendous possibility of achievement. If we could produce electric effects of the required quality, this whole planet and the conditions of existence on it could be transformed. The sun raises the water of the oceans, and winds drive it to distant regions where it remains in a state of most delicate balance. If it were in our power to upset it, when and wherever desired, this might life-sustaining stream could be at will controlled. We could irrigate arid deserts, create lakes and rivers, and provide motive power in unlimited amounts. This would be the most efficient way of harnessing the sun to the uses of man. The consummation depended on our ability to develop electric forces of the order of those in nature. It seemed a hopeless undertaking, but I made up my mind to try it, and immediately on my return to the United States in the summer of 1892, after a short visit to my friends in Watford, England, work was begun, which was to me all the more attractive because a means of the same kind was necessary for the successful transmission of energy without wires. At this time I made a further careful study of the Bible and discovered the key in Revelation. The first gratifying result was obtained in the spring of the succeeding year, when, reaching a tension of about 100 million volts, 100 million volts with my conical coil, which I figured was the voltage of a flash of lightning. Steady progress was made until the destruction of my laboratory by fire in 1895, as may be judged from the article by T.C. Martin, which appeared in the April number of the Century magazine. This calamity set me back in many ways, and most of that year had to be devoted to planning and reconstruction. However, as soon as circumstances permitted, I returned to the task. Tesla's first announcement of a possible plan for wireless broadcasting was made in a lecture before the Franklin Institute in Philadelphia in February 1893. It would not require a great amount of energy to produce a disturbance perceptible at great distances, or even all over the surface of the globe. Quote, unquote. By May of 1893, Tesla was wowing the crowds at the Chicago World's Fair with alternate current right at the height of the War of the Currents. Already in a meeting of the National Electric Light Association on 1893, Tesla told, "Practical to disturb, by means of powerful machines, the electrostatic conditions of the Earth, and thus transmit intelligible signals and, perhaps, power." His overwhelming success with AC and his plans for wireless transmission of intelligence and power came as a deep thorn in Edison and Morgan's sides after they snubbed funding his wireless ideas a few years earlier. Meanwhile, experiments and discoveries in electromagnetic radiation and the propagation, manipulation, and detection thereof would yield to advances in wireless telegraphy, telephony, and radio wave signaling, and would fire up the synapses of imagination, innovation, and invention in minds all around the world. According to Wikipedia, the idea of wireless communication predates the discovery of radio, with experiments in wireless telegraphy via inductive and capacitive induction and transmission through the ground, water, and even in train tracks from the 1830s on. James Clerk Maxwell showed in theoretical and mathematical form in 1864 that electromagnetic waves could propagate through free space. It is likely that the first intentional transmission of a signal by means of electromagnetic waves was performed in an experiment by David Edward Hughes around 1880, although this was considered to be induction at the time. In 1888, Heinrich Rudolf Hertz was able to conclusively prove transmitted airborne electromagnetic waves in an experiment confirming Maxwell's theory of electromagnetism. After the discovery of these Hertzian waves, it would take almost 20 years for the term radio to be universally adopted for this type of electromagnetic radiation. Many scientists and inventors experimented with wireless transmission, some trying to develop a system of communication, some intentionally using these new Hertzian waves, some not. Maxwell's theory showing that light and Hertzian electromagnetic waves were the same phenomena at different wavelengths led Maxwellian scientists such as John Perry, Frederick Thomas Troughton, and Alexander Trotter to assume they would be analogous in optical signaling, and the Serbian-American engineer Nikola Tesla to consider them relatively useless for communication since light could not transmit further than the line of sight. In 1892, the physicist William Crookes wrote on the possibilities of wireless telegraphy based on Hertzian waves, and in 1893, Tesla proposed a system for transmitting intelligence and wireless power using the Earth as the medium. Others, such as Amos Dolbear, Sir Oliver Lodge, Reginald Fessenden, and Alexander Popov, were involved in the development of components and theory involved with the transmission and reception of airborne electromagnetic waves for their own theoretical work or as a potential means of communication. Over several years, starting in 1894, the Italian inventor Guglielmo Marconi built the first complete, commercially successful wireless telegraphy system based on airborne Hertzian waves, radio transmission. Marconi demonstrated application of radio in military and marine communications and started a company for the development of and propagation of radio communication services and equipment. The meaning and usage of the word radio has developed in parallel with developments within the field of communications and can be seen to have three distinct phases: electromagnetic waves and experimentation, wireless communication and technical development, and radio broadcasting and commercialization. In an 1864 presentation published in 1865, James Clerk Maxwell proposed his theories and mathematical proofs on electromagnetism that showed that light and other phenomena were all types of electromagnetic waves propagating through free space. In 1886 through 88, Heinrich Rudolf Hertz conducted a series of experiments that proved the existence of Maxwell's electromagnetic waves using a frequency in what would later be called the radio spectrum. Many individuals, inventors, engineers, developers, and businessmen constructed systems based on their own understanding of these and other phenomena, some predating Maxwell and Hertz's discoveries. Thus, wireless telegraphy and radio wave-based systems can be attributed to multiple inventors. Development from a laboratory demonstration to a commercial entity spanned several decades and required the effort of many practitioners. Patents played a role in another case of historical amnesia, that of Jagadish Chandra Bose, who should get honorary mention for not just his contribution but his ethic. In the 1890s, he discovered that galena crystals could pick up radio signals, using his discoveries to later pick up on the nervous system of plants. Bose was not so concerned about things such as patents and shared his work openly with others. Despite letting a friend persuade him to file a patent for a detector for electrical disturbances, Bose objected to science for the sake of profit, and he ultimately let that patent lapse. Marconi is thought to have used a Bose-designed device to receive the first transatlantic wireless signal in 1901, an accomplishment that made his name famous worldwide. Bose went on quietly making advances in radio and refusing to cash in. If you had seen the greed and hankering after money in the United States, he lamented to a friend in 1913. Money, money! What a terrible, all-pervasive greed. And indeed, the work that Guglielmo Marconi did rested on the shoulders of others. His own patent for work in wireless radio telegraphy that he gets credit for inventing, radio, started in 1894 and uses 7 Tesla patents. Also in 1894, Sir William Preece delivers his papers on electrical signaling without wires using multiple Tesla patents. On March 13, 1895, a fire would ravage and burn to the ground Tesla's lab where many of his electrotherapeutic and life-saving medical devices were as well. The scientific, medical, and financial loss to all mankind was incalculable. The fire came after Tesla envisioned a new system of small power units for both home and industrial use that would require a small monthly fee and that could draw sufficient power to operate factories and homes alike. Electrical usage could be metered. The superiority of this new broadcast power system was obvious to all who observed it in operation. He succeeded in making radiant electricity safe for human use. It would simply travel around conductors if made to impulse quickly enough. Only specially tuned receivers could properly intercept the radiant power of utility. Only 3 years earlier, in 1892, he had accidentally discovered the radiant electrical effect and dreamt of safely sending electrical power without wires. Now, in 1895, he had realized his dream. Sometime shortly after a meeting with J.P. Morgan about Tesla's new discovery of the electric ray for free wireless energy, and just hours after turning down and away one of Morgan's agents, who had offered him a bribe to accept contracts that would have placed Morgan in control of this system, Tesla's 5-story laboratory burns to the ground. Despite the devastating loss to his work, Tesla is lucky to have survived, having been spared from the fiery demise after taking to a whim of having an unusually late dinner at Delmonico's instead of his usual working late. Tesla survived Morgan's blow of revenge, having not just refused him his work, but having also turned away the advances and attentions of Morgan's daughter Anne as well, who had, up until that night's inferno, relentlessly been pursuing Tesla at every turn. After the fire, and much to the worry of his friends and loved ones, Tesla disappeared for 2 weeks, re-emerging a new man with new resolve in his heart and mind. Tesla cleverly cornered the tycoon publicly by making a plea for money from Morgan in the paper requesting help. Morgan, for fear of being charged with the destruction of Tesla's lab in the public mind, paid Tesla $150,000 to keep quiet on his involvement in the fire, being at a disadvantage since Tesla survived his murder attempt. 1896 was an eventful year for Tesla and history, as Westinghouse and Tesla won the bid for building a hydroelectric power company at Niagara Falls that would start the electrification of the world, lighting up Buffalo, New York on November 16, 1896, using the Tesla polyphase induction patent. In 1896, Tesla was working on oscillations to be used for energy transfer. The idea was to create a steam-powered oscillator able to create various frequencies. If the frequency matched the resonance frequency, a receiving device should transform the mechanical oscillations back into an electric current. New York World Magazine had quoted Tesla 2 years earlier in 1894, saying, "He is viewed by authorities as the very greatest man living in the line of abstract electrical research, and quote him saying, "If a mass of metal as big as the Delmonico restaurant in which we eat, possessing 10,000 times the resisting force of the most finely tempered steel, should be caused to vibrate with 1/1,000,000th of the rapidity of light, producing electric vibrations in ether, would simply vanish in the air like smoke. It would disappear into separate atoms too small to be seen, and would never be heard of again." In 1897, the device was ready, and in 1898, he supposedly managed to oscillate his laboratory at 48 East Houston Street, New York, enough that alarmed neighbors called the police and ambulance, fearing an earthquake happening. Tesla later explained this principle to reporter Alan L. Benson, who published in February 1912 an article about Tesla's resonator in the World Today magazine. Tesla imagined using the waves generated by his invention for peaceful applications. One device would transform electricity into vibrations. Tesla would then use the rocks in the underground to send the vibrations to a second device. This receiving device would pick up the vibrations and transform the oscillations into electricity to be used locally. In fact, the device, consisting of a piston vibrating in a cylinder, was already powerful enough to vibrate an entire building. Just one precaution was necessary. If powerful enough, his machine could match the Earth's frequency, causing even earthquakes. Still, in the 1900s, Tesla imagined using smaller devices to relieve energy from Earth, in this case, to prevent earthquakes. However, the telegeodynamics system used by Tesla never managed to get beyond the prototype. The device was in reality not powerful enough to send energy far enough. Dampening of the oscillations by structures in the underground was far too strong. Another idea of Tesla was more successful. He imagined using the oscillations generated by his device to prospect the underground. Waves sent into the underground would be reflected by obstacles or different rocks. Observing the returning waves, a geologist may be able to see the underground. As an aside, this idea was actually adapted for use by the petroleum industry, and is used today in a modified form with devices used to locate objects at archaeological digs. By then, Nikola Tesla and Samuel Clemens, aka Mark Twain, were good pals. It is alleged that Tesla once cured Mark Twain's constipation with his oscillator machine, which was the least Tesla could do, considering he alleged that reading one of Mark Twain's books years earlier helped cure the younger Tesla when he took ill. Twain lived just a few blocks from Tesla's laboratory at 35 South 5th Avenue and was known to visit Tesla's lab. The pair also known to get into their share of trouble after a night at the Gentlemen's Club. A regular visitor to the laboratory, it is said that Mark Twain was standing on the vibrating platform, enjoying it with awe and excitement, extolling its therapeutic effects, while repeatedly ignoring Tesla's warnings to get down. But he was made aware of its laxative effects soon enough, and before long was forced to run abruptly to the nearest water closet. The same high-frequency oscillating laxative machine of sorts was also Nikola Tesla's earthquake machine, that shook violently as it moved, shaking his building, nearly bringing down its walls. Originally designed to provide a stable source for the frequencies of alternating current, this small device also enabled Tesla to try out his experiments in resonance. Every substance has a resonant frequency, which is demonstrated by the principle of sympathetic vibration, such as the example of a wine glass that is shattered by an opera singer. If this frequency is matched and amplified, any material may be literally shaken to pieces. A vibrating assembly with an adjustable frequency was finally perfected, and by 1897, Tesla was causing trouble with it in and near his neighborhood. Reporter A.L. Benson reported further, "He set the vibrator in tune with a link. For a long time, nothing happened, and vibrations of machines and link did not seem to coincide. But at last they did, and the great steel began to tremble, increased its trembling until it dilated and contracted like a beating heart and finally broke. Sledgehammers could not have done it. Crowbars could not have done it. But a fusillade of taps, not one of which would have harmed a baby, did it." Tesla was pleased, but not satisfied, and went out to find another building of 10 stories of steel framework without a brick or a stone laid around it, and nearly brought it down along with the workers he sent running off of it, thinking there was an earthquake. Tesla escaped with his device in his pocket before the police were called out. With the same vibrator, he could have dropped the Brooklyn Bridge into the East River in less than an hour. Tesla finally destroyed the machine one day, according to one source, because the device bonded to the metal on an atomic level, and so Tesla was unable to get to the controls. But regardless of whether that's true or not, he most probably legitimately feared bringing down the whole building with it. He later mused to reporters that the very Earth could be split in two, given the right conditions. The detonation of a ton of dynamite at intervals of 1 hour and 49 minutes would step up the natural standing wave that would be produced until the Earth's crust could no longer contain the interior. Again, he called his new science telegeodynamics. Newspaper artists at the time went nuts with all manner of fanciful illustrations of this theory. Tesla's fertile imagination posited a series of oscillators attached to the Earth at strategic points that would be used to transmit vibrations to be picked up at any point on the globe and turned back into usable power. Since no practical application of this idea could be found at the time that would make money for big investors or other philanthropic souls, one can't effectively meter and charge for power derived in this way, the oscillators fell into disuse. In 1898, Tesla demonstrated a boat that used a coherer-based remote control, which he called teleautomaton, during an electrical exhibition at Madison Square Garden, sending wireless signals a short distance to remotely trigger the boat. And in 1899, Tesla gets funding for his Colorado Springs lab from a few of his friends, especially from the Colonel John Jacob Astor. By June 15th, 1899, Tesla began coiling and runs his electric field tests, where he illuminates incandescent lamps wirelessly in a field surrounding his lab in an experiment to illustrate an inductive effect of an electrical oscillator of great power. On September 3rd, at 3:03 a.m. of 1899, Yakutat, Alaska experiences earthquake number 333, which lasted for 27 days and is credited by one researcher as being a highly unusual, unprecedented, and unrepeated man-made event. The San Francisco Examiner of September 25, 1899 contains a letter sent from Yakutat, Alaska, September 17th, by the Reverend Sheldon Jackson, giving a vivid and incredible account of a swarm of earthquakes beginning on September 3rd, going all the way through until the 29th of September. Did Nikola Tesla cause a 27-day world record earthquake in 1899? Now, according to the USGS, the 1899 earthquakes at Yakutat Bay, Alaska lasted 27 days, from the 3rd of September to the 29th, and included 4 or 5 world-shaking disturbances and hundreds of minor shocks. During 4 weeks, there was almost constant palpitation of this part of the Earth's crust. The shocks were most severe on September 3rd, 10th, and 23rd, and were great on the 15th, 17th, and 26th, and 29th. On the 10th, there were over 50 small shocks and 2 world-shaking disturbances. The greatest faulting took place on September 10th. The greatest uplift that had ever been recorded in the history of the world took place on September 10th, 1899. Quote, "All the repeated acts or operations I performed had to be divisible by 3, and if I missed, I felt impelled to do it again, even if it took hours." Nikola Tesla. If you only knew the magnificence of the 3, 6, and 9, then you would have the key to the universe. Nikola Tesla. In an article entitled Nikola Tesla Dreamer, published in The World Today in February 1912, Tesla states that it would be possible to split the planet by combining vibrations with the correct resonance of the Earth itself. He further states that, "Within a few weeks I could set the Earth's crust into such a state of vibrations that it would rise and fall hundreds of feet, throwing the rivers out of their beds, wrecking buildings, and practically destroying civilization." Did Tesla's experiments with the most powerful oscillator have anything to do with this tectonic uplift? Further research is needed to answer this question definitively, so for now we leave this in a gray area, keeping in mind that this was in line with what Tesla was talking about doing with his great oscillator, and overlapped the time of his Colorado Springs experiments with it. regardless of whether this is a great Tesla synchronistic moment, or whether he actually did affect the Earth's crust from that far away using his oscillator, this much is sure, that by the end of the 1890s, Tesla had come to the conclusion that it might be possible to transmit electrical power without wires at high altitudes, where the air is thinner, and consequently more conductive. And in 1899, Tesla would tell Morgan, "When wireless is fully applied, the Earth will be converted into a huge brain, capable of response in every one of its parts." In a patent US 645576 system of transmission of electrical energy, March 20th, 1900, Tesla claimed, "It has become possible to transmit through even moderately rarefied strata of atmosphere electrical energy to practically any amount and to any distance." Tesla's Colorado experiments and patents explain artificial rain is created by ionizing the air with his tower. Various weird phenomena were noted in Tesla's Colorado Spring Lab experiments, such as a mass of butterflies swirling above it during one such experiment. And in another experiment, Nikola Tesla became the first to scientifically document the artificial generation of fog by atmospheric ionization, later reporting at a presentation of the Edison Medal to Nikola Tesla, minutes of the annual meeting of the American Institute of Electrical Engineers held at the Engineering Society's building in New York City years later on May 18, 1917. "In Colorado, I succeeded one day in precipitating a dense fog. There was a mist outside, but when I turned on the current, the cloud in the laboratory became so dense that when the hand was held only a few inches from the face, it could not be seen. I am positive in my conviction that we can erect a plant of proper design in an arid region, work it according to certain observations and rules, and by its means draw from the ocean unlimited amounts of water for irrigation and power purposes." And ladies and gentlemen, boys and girls, this brings us back to the claims that yours truly is making. We have only begun to tell Tesla's tale and how it unfolds into the history of a weaponized Doppler radar system. And still, you see, the claims we're making here, the Doppler radar is weaponized microwave beam technology, and that it has risen up in our midst, and not only is being used to steer and weaponize the storms, but is being used in daily weather operations to harvest the hydrological cycle and steer it where it is ordered and programmed to go instead. And it, along with the cover-up and minimization of the chemical and aerosol degradation to our environment, which we will get into in later episodes, is the way bigger problem than CO2, and is why global warming doesn't stand a chance to stop, and why, if we do not realize this in critical mass soon enough, we are and will continue to be in a world of hot water. To be continued.